From basics to brilliance, understanding the power of AES encryption. Data security management threats have expanded rapidly, with enterprises as the main targets. Hackers know that digital information storage space is the norm. This sets a precedent to balance data availability, simplicity of use, and security, allowing daily operations while protecting sensitive data. Companies must ensure that data is easy to operate on a daily basis and maintain confidentiality. To resolve this issue, the Advanced Encryption Standard, AES, was created, which is now the Data Encryption Standard. In this blog, we'll explain the AES encryption algorithm, its characteristics, security capabilities, and how eShare.ai is used to protect user data. Key takeaways. AES is the most popular and secure symmetric encryption algorithms method, protecting VPNs, Wi-Fi networks, apps, systems, and more. AES encrypts data securely with 128-256-bit keys utilizing block ciphers with many substitution, shifting, and mixing rounds. The algorithm is faster than Data Encryption Standard, DES. AES supports several key sizes, 128, 192, 256 bits, and operating modes for security and performance. It also works well across platforms. Even with immense computational power, proper AES encryption algorithms make data nearly hard to decrypt without the key. It resists recognized attacks. AES interoperability, speed, flexibility, and strong security help companies of all sizes protect sensitive data. What is AES? AES is a symmetric block cipher method that encrypts 128-bit blocks with 128, 192, or 256-bit keys. It is widely used to encrypt electronic data and protect against all known attacks. NIST founded AES in 2001. It is now a popular symmetric key encryption technique. Key lengths and security strengths distinguish the three main Advanced Encryption Standard encryption methods, AES types. 1. AES 128 employs a 128-bit key for 10 encryption key rounds. For Wi-Fi networks and messaging services, AES 128 provides enough protection with over 3.4 quadrillion key combinations. 2. AES 192 employs a longer 192-bit key for 12 encryption rounds. This has 6.2 billion keys, making it ideal for critical corporate networks and secure file transfers. 3. AES 256 uses the strongest 256-bit key length, 14 rounds of encryption, and 1.1 septillion keys. AES 256 is used for sensitive government communications and critical infrastructure encryption algorithm due to its large key space. All AES encryption algorithms have been rigorously tested and are secure against known attacks when used properly. AES's extensive use across many technologies proves its data security management reliability. AES encryption process. Encrypting and decrypting fixed-length blocks of data, 128, 192, or 256 bits, involves replacements, permutations, and mixing procedures. In AES Advanced Encryption Standard, the same symmetric key is utilized for encryption and decryption. The process is organized in a total of 5 steps, and AES encryption has 4 transformations every round. In this process, subbytes, shift rows, and mix columns are included, and all steps except mix columns are repeated in the final round. The input plaintext block ciphertext has been output. Reverse operations are reversed to decrypt. Decryption round keys is acquired directly from the key schedule. AES features include: AES is a prominent data securing algorithm. These properties make it a strong encryption algorithm. Cryptography symmetric, AES uses the same key for encryption and decryption. This arrangement uses different keys for each step, unlike others. Key dimensions, AES key sizes include 128, 192, and 256 bits. These versions indicate that greater encryption requires larger keys. However, this requires greater computational resources. Safe and effective, one encryption algorithm without practical cryptanalytic assaults is AES. Its hardware and software implementations are also quick and efficient. Popular standard, wireless networks, VPNs, SSL/TLS for web browsing, and others use AES by default. Open source, standard AES is open. It's free and can be used in any program or hardware without royalties. Where AES encryption is used. AES encryption has many public and private uses. Common AES uses include encrypting VPN traffic, enhancing Wi-Fi security, password protection managers and mobile apps. AES is also used in full disk encryption, file compression tools, programming libraries, government/military communication systems, and quantum computing research data storage and communications. Strong brute force resistance and effective key sizes of 128 bits and above have made AES encryption algorithms a trusted and essential feature of secure data sharing globally. Is AES safe? Highly secure AES. Wide use and cybersecurity experts' studies have proven its cryptographic attack resilience. Although AES encryption is secure against cryptographic assaults, it is not immune to other hacking methods. Still, side-channel attacks and social engineering assaults can compromise the cryptosystem's physical implementation rather than its encryption algorithms. Advantages of AES encryption for your business. AES encryption has many advantages for enterprises of all sizes. An advantage of AES is its flexibility, allowing for encryption using 128, 192, or 256-bit keys. Even the 128-bit version is highly safe by today's standards, letting enterprises balance security and performance. AES works with several computer languages and operating systems, making it globally recognized and compatible. This indicates it suits a company's tech stack well. Furthermore, the AES procedure is easy and efficient, allowing for quick data encryption standard and decryption. This speeds processing without compromising security. AES uses less memory and computer power than traditional encryption technologies. For organizations concerned about technological costs, AES is affordable. Companies that handle sensitive data and desire hack-resistant cybersecurity benefit from its widespread usage and open security standards. eShare.ai employs AES encryption to safeguard your crucial data. Ensuring data security management is of utmost importance when storing data on the cloud and the Internet. To secure data, choose a cloud storage service platform such as eShare.ai, which implements the most robust security encryption technique and is validated by cybersecurity experts. In order to provide the utmost level of cloud security, we employed the AES and MD5 algorithms. Additionally, ensure the acceptance of cloud computing storage among cloud service users. We undertake further efforts by adhering to compliance regulations. eShare.ai primarily concerns itself with ensuring cloud data security and privacy, particularly in relation to the cloud storage and utilization of data in cloud environments. Our objective is to foster confidence between cloud service providers and consumers by safeguarding data in the cloud storage environment. Thanks for listening to vBlog. Please like, share, and subscribe to our YouTube channel for more content.